Hello, welcome to the premiere episode of Debbie Presents Fun with Distributed System. Only one episode for this season. If you haven't heard about web prefetching, great, that's our topic for today. So I found this term in chapter 7, where the book talks about caching and replication in the web. I was curious about how this technique goes with caching, and I found a paper for it. A survey of web caching and prefetching written by Ali et al. In 2011. Since we are going to learn about caching in class, I'll only cover the prefetch part of this paper. Let's start from the definition of web prefetching. As its name indicates, it is a feature that fetches some web objects before user actually requests them. It fetches resources in the background and stores them in the browser's cache. So if the user clicks on a prefetched link, the content can be loaded instantly. Many web objects can be prefetched, including a variety of media files and style sheets. Imagine you load a web page in a browser. It takes some time to show the content, and you find a button that says "Click me" on it. While you are hesitating whether or not to click it, let's say on April Fool's Day, the prefetching feature predicts you are most likely to proceed with your curiosity. So it starts to fetch the content of the page linked to that button and store it in the cache. When you finally follow your heart to click on that button, the page content has already been cached, so the page will load in no time. From this example, we can tell that web prefetching can increase cache hits and reduce user-perceived latency. Don't mix up prefetching with caching. The paper calls web prefetching an useful technique that can complement a web caching mechanism. Because the web caching uses temporal locality to predict revisiting requested objects, while the web prefetching uses the spatial locality to predict next related web objects of the requested one. Several studies have shown that the combination of caching and prefetching doubles the web performance compared to caching by itself. It can potentially improve latency up to 60%. Table 4 in the paper summarizes the types of prefetching according to location. The client-based prefetching concentrates on the navigation patterns of a single user across many web servers. The proxy-based prefetching focuses on a group of users, also across many web servers. While the server-based prefetching concentrates on all users accessing a single website. According to the paper, proxy-based prefetching is considered more effective and more accurate in predicting the correlated pages of many websites in similar interests for more homogeneous users. The existing prefetching algorithms can be classified into two main categories based on the data taken for prediction, says the author in 2011. Content-based prefetching predicts future user requests, depending on the analysis of web page contents. This approach is not recommended to be implemented at the server side, because the high load for parsing every web page served can negatively affect the server service time. History-based prefetching makes predictions based on observed page access behaviors in the past. Many studies were interested in enhancing the techniques of this category. Its algorithms can be classified into 4 types: dependency graph, Markov model, cost function, and data mining-based algorithm. The last one can be further categorized into 2 classes: association rules and clustering-based algorithm. A Among these algorithms, the ones based on data mining and Markov model are more commonly used. The paper also mentions the data mining techniques have been utilized effectively in web proxy prefetching area with great potential. However, web prefetching isn't perfect. If we are given a web page with lots of buttons that link to different web pages, how do we know which buttons the user may click on? If we prefetch all the resources just in case, what if the user won't request all of them? In this case, web prefetching will result in an increase in network traffic, as well as web service load. It will also not make good use of the cache space. Therefore, we should design the prefetching approach carefully to overcome these drawbacks. To analyze the efficiency and performance of different prefetching techniques, the paper introduced several performance measures. Precision is the ratio of prefetch hits to the total number of objects prefetched. Recall is the ratio of prefetch hits to the total number of objects requested by users. There are also traffic increase and latency per page ratio that can be used to evaluate prefetching techniques. Nowadays, fast website rendering is a must-have in the fast-paced world. New prefetching techniques are formed to enhance web performance in a more precise manner. Here are some terms used in web development today. They are called resource-hence directives that can be used to improve web performance for different scenarios. Although they might look quite like each other, we can tell them apart by the purposes they serve. For example, prefetch is for future navigation, while preload is for current navigation. And prefetch fetches several web objects, while prerender renders the entire page. You can decide which features to use for different scenarios in order to limit the network traffic and bandwidth usage. New web prefetching techniques take advanced machine learning approaches to provide better data-driven user experience. This is a still developing field, and we may observe exciting inventions based on the prefetching technique that better enhance our web browsing experience. If you're interested in speeding up your website with the prefetching technique, go check it out. Thank you for watching, and have a nice day.